we have 4 vocab words today. Yes, we have already kind of done 2. First vocab word, domain. Second vocab word, range. We have talked about domain and range already. What's domain?
Domain is x's.
X values. Domain is x values of a graph or of a function or of a situation.
What's the difference?
X between the x-intercept and x values. X values mean any number, any x values in the entire line. So here,
okay.
those all x values, not just where it crosses the x-axis. Okay, so we're talking about domain and range today, x values and y values, and then 2 other vocab words, discrete and continuous. Discrete and continuous are the 2 types of graphs that we have. Discrete is when we leave a graph as just the points. Continuous is when we have a connected graph. Yes. Yes.
What does this mean?
Discrete.
About this between D-I-S-T-I.
Oh, distinct meaning individual, like specific points. Distinct means they're each their own. We're not connecting things together. So when we have domain and range, x values and y values, right? When we have domain and range, depending on whether it's discrete or continuous, we write them differently. We write the x values and y values differently depending on what type of graph or situation it is. If it is discrete, it is a specific number. There are specific numbers for x and y. We write them out in a list. They're going to be a list. We kind of did this already. Do y'all remember when we talked about those brackets?
Yeah.
That's called a solution set, and that's what we put around our list of things. So we have our solution set. So inside of those S brackets is where we're going to be putting a list of numbers, the list of the X values, the list of the Y values. So to be able to figure out, is our graph this discrete or continuous, we have situations. There are some situations that are discrete, some are continuous. The trick, can there be decimals for your X values?
Yes.
If it can only be whole numbers or specific numbers, that is a discrete graph or discrete function. If it can have decimals or things keep going, then it's continuous. So we're going to look at number 4. The number of suitcases lost by an airline in a month. Could you have part of a suitcase lost? No, you cannot have part of a suitcase lost, which means this is a discrete situation. Your graph would have whole numbers only for X values. The question we're circling yes or no, is it discrete? So yes, this is discrete. Okay, on to number 3, the pet store. Number of pets sold at a pet store in a year, is that discrete or continuous? Discrete.
You can't cut a pet in half.
Right, you aren't looking at
You can, but
total cost of staying in a hotel after X number of nights.
No.
Is that discrete or continuous?
No.
yes.
No.
No, because you can split it in half.
No.
No, you can have a limit.
No.
No.
No. One.
All right, that one is discrete because if you ever go and say how many nights you're staying at a hotel, you get a drop-down option. The drop-down option is 1, 2, 3, 4, 5, 6. It's not partial. You are staying at that hotel that night or you're not. All right, and then the first one, the height of a soccer ball from the ground after it's kicked.
No.
Yes.
That is not discrete because think of as you kick a ball in the air,
You can't.
it keeps going, it continuously just keeps going, and then hits the ground. It's not pixels and like it's not floating and like all of a sudden it's here and then moves to the other side. That's not how it works. So when it is not discrete, that graph is called continuous. When it is not discrete, that graph is called continuous. So When it comes to, I'm gonna drop the stop. Okay. Discrete and continuous, it does not matter if they're linear. It can be anything to be discrete or continuous. It doesn't matter if they're linear, it doesn't matter if it makes a function or not, it's just, are the points on a graph, or is it a connected continuous graph? Okay. Down the bottom. Once we have something that is discrete, so all of these examples from here on out are going to be discrete. Depending on when it's discrete, there's a certain way to write our domain. What does domain go with? Which values?
X value.
So our x values. So there's a specific way to write our domain, write the x values, and write the range, which are our y values. So for domain, if we have ordered pairs, literally just list the x values. It's just what are the x values from our ordered pairs? -2, 0, 2, 3. And then when it comes to writing our range, our y values, it is really just list the different y values. 8, 2, -4, -7. Same thing with a table. If there's a table and it doesn't tell you that the table is a sample of something, or if it just says like these are the only numbers we have, then it's discrete. Our x values are our domain. Y values are our range. Yes.
What if the x value is 1.756?
That's fine.
It's
It can, as if it tells you specific numbers, then it's okay.
also it's still this.
It could be, yes.
What about like
So discrete is when there's specific numbers that can be the x values.
also what about
So if some of the chosen x values are decimals, then that's okay. It's just in a word problem, that's kind of the trick to help.
what?
If we have a word problem, decimals, if you can have a decimal or not, that's our trick to help for most problems.
Okay.
What part? What you need help with?
Like how much?
Y values can be decimals. It's the x values that we want to say. So then for a table, domain 1, 2, 3, 4, and then range 350, 7, 1050, and 14. If it's the graph, what's the domain going to be? So look at this graph over here.
The next value.
The x values from the graph. So -1, 1, 3, and 5. And then for the y values from those points. 1, 2, 3, and 4. For a mapping, mappings are always going to be discrete though. Because mappings are just showing specific points. So our x values, -3, 1, 4, and 6. And then for our y values, 1.5, -0.5, -8, and -13. Last part for an equation. Most equations are going to be continuous. How you will know that equations are not continuous is when it has something like this with it, where it says this is the specific domain, or if it said this is the very specific range value. So if you're given an equation and then said only use these points, that's how you know that it's going to be discrete instead of continuous. So our domain is 0, 1, 2, 3, and 4. How would you get the range values?
Plug
Plug them into X.
Right. Well, you gotta plug the numbers in for x. So 30 times 0 plus 50.
50.
30 times 1 plus 50. Right. So you're plugging in the domain values to get your range values. Okay. The last part is a word problem. So John's balance on a gift card to Jumbo Juice is $25. He plans to use his gift card to purchase his favorite drink, which costs $2.50. The remaining balance on the gift card is a function of the number of drinks purchased. So we need to write an equation. That's our first step. For our equation, what is happening in that problem? He's buying juice, and he has a gift card. So what is happening to the gift card? Money is coming away from it. That means we should have what kind of graph? Negative. Negative, which means our slope should be negative. What's the slope going to be?
Negative 2.5.
Yep, because that's the amount of money that's going down. And then add in his starting amount. How much does he start with on the gift card? We're going to skip the graph part. If we were to graph it, it would be points on the graph. Because why is this discrete? Yes, Austin.
Because each drink he buys is a certain amount. The card is just being drained over time.
Correct. It's not being drained over time. It's taken out at a specific time after one drink, after two drinks, after three drinks. So, reasonable domain. Domain goes with our x values. And what is x representing in that equation?
So
Negative 2.5 is our slope. What is the variable representing? Drink. So, if it's a discrete situation, when we write our domain, we make it a list. What's the smallest amount of drink that he's going to purchase? You can follow. 0. You could have 0 drinks.
You don't buy it.
Okay. Then 1, 2, 3. How many do I have to keep listing?
Until
All of them, but when is he going to run out of money?
you just divide 25 by 2.5.
100.
It would be 10 drinks.
How many drinks did he get?
10.
10 drinks.
Yeah.
And they're $2.50 each, and he has $25. So
Who's math?
Multiply by 10. equals 21.
Like an extra large?
Or just
no,
divide
this is
it.
saying his drink change. He has his favorite drink, and that's all he's buying with it. Okay. Now for the range. Range goes with our y values. What is the range representing? What is that variable of y representing in the problem?
amount of money.
His money. So, money that he has. What's the smallest amount of money that he's going to have in his card?
25.
Okay. And what's the next amount of money he might have?
25.
No.
2.5.
2.5, because each drink is $2.50. So he could be completely out of this gift card with $0. He could have $2.50 left. He could have $5 left. $7.50, $10, $12.50, $15, $17.50,
Wait, what?
$20, $22.50, and most amount of money starting with on his card, $25. Flip over to the other side. If you don't have a discrete situation, that means you have a continuous situation. Continuous is when we can include all of the things in between. It's a range, or it's a it can be any number in between. So when we write it, we have to write our domain and range differently if we have continuous graphs. We write it with inequality notation.
Yeah, so I wouldn't say.
Okay. We briefly, we did I think 1 or 2 problems that involve some inequality notation. It's when you have x inside of those inequality signs
Oh, yeah.
or y inside of those inequality signs. Where on the left side we wrote a number that was the smallest number, and then on the right side we wrote the biggest number. We're gonna do examples of it.
Oh, so
Before we go through examples of writing that domain and range and inequality notation, more practice on discrete and continuous. The amount of gas remaining in a fuel tank after driving X number of miles. Is that discrete or continuous? Continuous. How do you know that?
It's constantly going down.
When you're driving, that amount, your gas amount, is constantly moving. It's being taken out. And then for number 2, the number of fish on lake at a given day. Discrete. Right. You're not including partial fish of anything. It is a fish or it's not. Okay. Now for domain and range when it comes to continuous. When it comes to a graph, if it is domain, which axis do you think we're going to look at? The x-axis. And if it's range, we're going to look at the y-axis. Now the other thing that we are going to be doing, we're going to be using inequality signs. So back to 6th grade. I don't know what grade. I don't remember what grade. If I told you x is greater than 2, graphing that on a number line, you would put it here and go that way.
Yeah.
Right? And then if x is less than or equal to 0, we would color in the circle and draw it that way. How come you would color in the circle or leave it?
If you color it in, it means it could be that too.
Correct. It's that inequality sign. It's an open circle if it was just greater than or less than. It was a colored in circle if it was equal to. That is going to come into play when we write our inequality notation. So if it is an open circle,
I remember this.
it's one of these symbols. And if it's a closed circle, it could be equal to. We're going to do number 6 first. So on number 6, that's the first we're going to do. We're going to D, domain, R, range. Domain goes with our x values. Every time we have a continuous domain, we can do this beginning setup. X in between 2 less than signs. That's our starting point. The number that's going to be on the left, go to your graph, go to the farthest left that is on that graph. What number is that at?
-5.
-5. And what kind of circle is it? Open. So that inequality symbol is going to say is just less than. Then go to the right. And what number is that going through? 5. And what kind of circle is it? So it's going to be equal to. And we just did the domain of that continuous graph. Now for range, we're going to do the same setup. Range, the y can go in between 2 inequality signs. For range, the lowest part, what's the smallest y value, the lowest part of that graph? 3. And what kind of circle is there? So it's going to say it's a less than, and then go to the top part.
6.
It's a 6, and it has a closed circle, so it's going to be equal to. It's going to include.
Easy.
So that is our domain and our range.
Insane.
We're going to go to number 5. For 5 for the x values, the farthest left and the farthest right. What is the smallest, the farthest left number? 0. Do you see an open circle? Do you see an arrow? If you don't see either of those things, then it is just default. It assumes to be a closed circle, so we can say it's equal to. So if you don't specifically see an open circle or an arrow, it is a closed circle, it's equal to. Then for the far right, what number are we at? Again, there's no open circle and there's no arrow, so it's equal to. Then for our range, y values.
0.
We can set it up the exact same start. Bottom up to the top. What's the lowest value?
0.
0, and there's no open circle or arrow, so equal to. And then what's the top part? And there's no open circle, so equal to. Now to number 4. So we're kind of going in backwards. On number 4 for a domain, go to the farthest left and then to the farthest right. What's on the farthest left?
-5.
-5 with a closed circle. So it could be equal to. And then to the farthest right. What's the farthest right?
Infinity,
Ooh, why do you say infinity?
because the lines keeps going,
Oh,
there's no end.
There's an arrow, which means it's going to keep going and going. So you are correct. Infinity.
That can actually be an answer.
Uh-huh.
Okay,
I get it.
Turn your paper sideways, draw an 8.
Yeah.
Okay, now for the range. Our range started off Y in between those two inequality symbols. The bottom all the way to the top. What is the lowest part?
Infinity.
Okay, but it's the lowest part is going down for forever.
Negative infinity.
Negative infinity is a thing, and that's our lowest part. What is Okay, then for the top part, what's the highest point on the graph? 3. And that's the closed circle, so equal to. Let's go to number 7. Okay, so number 7. Domain, farthest left to the farthest right. What is the farthest left x value? 0. Because it's our x values. And then what's the farthest right x value? Infinity. Look at the farthest right on a graph. It's an arrow, which means it's going to go to infinity.
Well, what if
No.
Y values.
Wait. I don't know.
The lowest to the highest.
30.
The lowest is at 30, and it could be equal to. And the highest is an arrow, so we're going to infinity. All right. Equations. If there is not an equation with extra things told to you, like you can only use these x values or only use these y values. So we have just a plain equation, nothing else. If you were to graph that equation, we talked about graphing the other day, that would have a y-intercept of 4 and a slope of -3. So down 3/1, we would draw the line and arrows, right?
Yeah.
Okay. Domain, that would be the x values. If I were to find the x values of this graph and went to the farthest part left and the farthest part right, what is on both sides? Arrows, that means it's going to go infinity in both directions. So when it comes to our inequality sign, it's negative infinity, which is less than x, which is less than infinity. That is the inequality notation of writing it. There is a word notation or words that we can use that mean the same thing. That is called all real numbers.
Yes.
All real numbers. So those two things are interchangeable. They mean the same thing. You could write either one in a blank and both would be correct. And then math people are extra lazy. So when there's a time to be able to make a symbol, instead of writing the words all real numbers, we have a symbol for it.
Oh!
It's double lines on that R.
What does that mean? Like,
It means all real numbers. So all three of those things I just wrote in pink all mean the same thing. You could write any one of those in a blank, and I would count it right if this was the problem. You could write the word all real numbers. You could write the symbol that means all real numbers. Or you could write all real numbers in that inequality notation.
What's the letter before?
All? No, it's an R with a double line. That just means all real numbers. Okay, now for the Y values, the range. It is the same thing, except yes, with Y. So negative infinity, less than Y, less than infinity, or all real numbers, or you write all real numbers with the R.
Can you just hold on to the other paper?